this video, I'm going to be doing a couple VSEPR examples. VSEPR stands for valence shell electron pair repulsion theory, and it just gives us a good way to approximate the 3D shape of a molecule. So the first example I'll be doing is beryllium chloride. Step 1 is always to count the number of valence electrons. So beryllium is in group 2 of the periodic table. So that means it has two valence electrons. Chlorine is in group 17 of the periodic table. So we know that that stands for 7 valence electrons. But I actually have 2 chlorine molecules, so each of them are going to bring 7 valence electrons, so I have to times that by 2. So the total number of valence electrons in this molecule is 16. That's step 1. So step 2 now is to take your guess. I guess that beryllium is going to be the central atom because I have 2 chlorines to go on either side of it. After I draw my guess, I just want to figure out how many electrons I've used from my total count. So there's 2 electrons in that bond and 2 electrons in this bond. That's a total of 4 electrons that I've drawn. So I have to subtract 4 from my valence electron count. That tells me I should have 12 electrons left to draw. So I'm going to put them first around my peripheral atoms. 6, 6, and that's a total of 12. So that's my final guess, and now this following step is to make sure that your guess is a good guess by checking formal charges of every atom. For the formal charge, I'm going to take the valence electron number, or the group number, subtract the number of lone electrons, and subtract half the number of bonding electrons. So for chlorine, we can look over here as well. It tells us that it came from group 7, or it should have 7 valence electrons. It has 1, 2, 3, 4, 5, 6 lone electrons, and in one bond it has 2 bonding electrons. So that's 7 minus 6 minus 1 for a formal charge of 0, which is the formal charge that we are looking for. I don't have to check the other chlorine atom because it looks the exact same, as in it has 6 lone electrons and a bond as the other chlorine, so it will also have a formal charge of 0. And then finally, it's just checking the formal charge of beryllium. Beryllium wants to have 2 valence electrons. It has no lone electrons and half of 4 bonding electrons because there's 2 bonds with 2 electrons each for a total of 4 bonding electrons. So that's 2 minus 0 minus 2 for another formal charge of 0. So once we have the right formal charge of 0 that we were looking for, we can just scrap all of this. We know our guess is good and just redraw it with Cl, Be, Cl. I don't have to fill in the electrons around the peripheral atoms as in the chlorines, but I do have to fill any lone electrons on the central atom, the beryllium, but in this case we didn't draw any, so I don't need to. The VSEPR notation of this is AX2 because there's 1x, 2 x's bonded to my A. And that leads us to the VSEPR 3D of a linear molecule. And in a linear molecule, the bond angles are 180 degrees. And that's all you need to know for the first example. The next example I'm going to do for you guys is NH3 or ammonia. So again, step 1, let's count the number of valence electrons. Nitrogen is in group 5 or group 15, sorry, so it brings 5 valence electrons. Each hydrogen in this molecule is in group 1, so it should have 1 valence electron. But I have 3 of those molecules. I have 3 hydrogens. Sorry, 3 of those atoms. So the total valence electrons in this molecule is 8. So step 2, I'm going to take my guess. I'm going to guess that the smaller number of atoms element, nitrogen, is going to go in the middle. And the atom I have more of, hydrogen, is going to go around the edges. And because of repulsion, I'm going to put those hydrogens as equally apart as they can get. So I picture it like a triangle, like that. So that's my guess. And then I want to count how many electrons I drew. I used up 1, 2, 3, 4, 5, 6 of my count. So now I only have 2 left to draw. And because I can't fill any around the hydrogens, because we know hydrogens don't take any valence electrons around them, my only option is to put them on the nitrogen. So my final guess looks like this. That's supposed to be an electron. And to know if we're right or not, we have to just check formal charges. So the formal charge of hydrogen, we know it wants 1 valence electron because it's in group 1. It has 0 lone electrons and half of the 2 electrons in that bond, which is 1 minus 0 minus 1, so a formal charge of 0, which is what we were looking for. And lastly, the nitrogen formal charge. Well, hopefully lastly, as in if this is a good formal charge close to 0, not a crazy high or big number. So we know nitrogen comes from group 5, 5 electrons minus 2 lone electrons for 1, 2, minus half of 2 bonding electrons, 4 bonding electrons, 6 bonding electrons, which is a total of 5 minus 2 minus 3, or a 0 formal charge, which is perfect. So now we know our guess is good. We can get rid of all of this and redraw our molecule as, actually let's do the VSEPR notation first. For the one we used to have here, should be A for nitrogen, my central atom. The number of peripheral atoms is 1, 2, 3, so X3, and then 1 lone pair on the nitrogen. So my VSEPR notation is AX3E, which is a trigonal pyramidal. And that shape in 3D would look more like this. My lone electrons on top of the nitrogen, a hydrogen coming out of the page at you, a hydrogen going back into the page, and 1 hydrogen from the side. Or if you wanted to look down on top of this molecule, that's where you would see those hydrogens out in a triangle, like this, with my lone pairs sitting right on top of this nitrogen. Hopefully that helps you with the 3D arrangement of these VSEPR drawings too. And that's it.